Okay, what happened? So next page. Okay, so we talk about the enabling IoT technology. Okay, the first sentence right here. The concept of the combining computers, sensor networks to monitor and control devices has existed for decades. Okay, so in IoT, we might use the computers, we might use the sensors and the network together with the what equipment. Or you say the devices, and they may use some idea for the IoT network. Some idea may have been used for the IoT industry, like ubiquitous connectivity or IP-based network, and some idea from the cloud computing, and actually depends what kind of the industry scale a company has, or some of the companies also implement the big data analysis together with the IoT. So as I mentioned just now, depends on the company or industry scale, and so how to connect to devices. So next page, it's going to let us know how to connect to the devices in IoT, and how to set up the basic connectivity in IoT. Okay, so right here, this talk presents the four basic connectivity ideas, or you can say the model for IoT. Okay, so the first one right here is device to device. Second one is device to cloud. The third one is device to gateway, and the last one backend and the data sharing. Okay, so the model highlights the flexibility in the ways that the IoT device can connect and provide value to user. Okay, so the final purpose is to provide value to the user. That means not only you need to make the connectivity work in your industry, you also need to make the IoT data produced by the model valuable to users. Okay, so that is so important to users. Also, it's so important to company both. Okay, so last sentence: data collection for data analytics and the process is needed. Okay, so maybe you think the data collection is so important. However, you cannot, so far, we cannot see data analytics is so important is to industry or IT. So that's okay. We're going to describe the ideas for this later, and we integrate the IoT data processing with the data analysis idea together for whole the eventually you know IoT and IoT data. So next one. Excuse me. Device to device. The first model we call device to device communication model. The model is very so simple, and And I got a drawback for the model. The drawback is you cannot have any doc file and any message stored by the model. That means you got something wrong in this model, and the manager or user cannot track the error. So I put the model in. In the first one to let you know that this one is so simple. Okay, so according to the first one description, the model present two or more devices that those devices can be connected together, by wireless network. So it's trivial. It's trivial. No any tricky thing right here. Just direct connection by wireless network, and the traditional way you can use Bluetooth Z-Wave and the ZB, and you also can use the up-to-date wireless technology to finish the same thing. However, just direct connection between the two devices or more than two devices. Okay, so as you can see the picture on the bottom right here, no any storage right here. So the same thing mentioned earlier, it got something wrong right here. You cannot track the error. You cannot track the error. So hold on, I need to have some water. So who are going to use the model? So industry can use the simple model, and if you are at home, you also can use the model for your smart home monitor. So for your 3C equipment. Okay, so it's the same idea implemented on industry. Nothing special right here. Nothing special right here. Just give you a basic communication model for wireless network implementation. Okay. Okay. Next one. Second one. I call the device to cloud. Okay. It looks. We add the term cloud. Everybody know the cloud. I mean, because we use Google every day. In my country, should be the same situation in your country. So everybody know the cloud. So if we put the cloud inside the model, that means that we make the something more complicated. Okay, so what does that mean? We got something called right here. We do believe that got some cloud computing inside. Okay, you say cloud computing. Do we need to implement cloud computing? Actually, it depends what kind of the levels you are going to implement on the cloud. So most of people implement on the top level on the cloud. So we don't need to care about the cloud computing. And if we use the Google for the cloud computing, and the Google is going to take care of the cloud computing, even distribute computing for us. So don't worry about this one. so now this model is called device to cloud. That means the cloud can save and store something for the communication information. That's right. And also can get something instruction return to the devices. The idea is also right, and even we also can extend the model. What does that mean? Not just return the instruction to devices. We also can return analysis feedback to monitor or computer. So if you use the SCADA, SCADA system in OT, you must know this kind of the system got a monitor inside, so they can control everything. If you got the card right here, and no problem, the card can return the analysis feedback to the monitor, and then give you more choice and for user or manager to make a right decision for your equipment and the devices. Okay, so also no problem, that can monitor your sensors. Okay, so right now we put the card under application service provider. Okay, application service provider, we treat this one as the cloud, and each country have their major provider in their providers, and those providers, I mean the ASP can provide a cloud service for users. Okay, so however, need to pay more money, monthly fee or annual fee for use. Okay, so it's impossible for free charge. Okay, so however, so we talk about the cloud, and some company don't use the ASP. I mean the from third party. They create the cloud by themselves. Okay, so that means it's not necessary for you to use third-party provider, and if a company or industry got enough money and got the private requirements, they think they need to create the private cloud for themselves. That should be okay, and the model should be okay with the idea. Okay, so this one is the second model. Okay, so just give you some basic idea, and you can extend the model to your idea by your requirements. So okay, question. No? Okay, next one. I find out one people want to talk in 2 hours. It seems a little bit tired to speakers. So I give a suggestion. To everyone, and I also give a suggestion to me. And I need to take a break between the 2 sessions, and one hour one section. Is that okay? If no response, that means should be okay. Okay, so okay, so the third model. Excuse me, some water. So IoT data, the idea is use the four basic model, communication model, and extend the four basic model to produce IoT data. Okay, so let us see the third one. In this model, more typically, okay, so I repeat the first sentence for everyone. Okay, so the model use ALG for short. The IoT device connect by ALG service. Okay, so it's weird. It's weird. Okay, so don't worry about the picture. I will give you a detailed description about this. Why I say so? Because most of the people have no idea about the gateway setting, and even no idea about what gateway is. Okay, so the model right here, should be similar to the model on earlier page. Okay, except one, the model add gateway between the model at the gateway among the sensor equipment and the providers. Okay, so it seems we need to explain the gateway first, right? Okay, so we got I provide the gateway description right here. Maybe everyone can take a look at the gateway description and the explanation right here. Okay, the gateway, okay, blah blah blah, and this means that there is application software operating on local gateway device, and which act as the intermediary between the device and the cloud service, and provides security and the other functionality such as the data and the protocol translation. Okay, so another thing I want to mention right here is a gateway allow different protocol for the communication. And maybe I give you the two. I give you the explanation, and right here you cannot understand gateway either. Okay, that's okay. I give you an example. So everybody know the e-commerce, right? E-commerce, right? What does that mean, e-commerce? And that means if you want to buy something on the internet by e-commerce system, you need to pay your money on the web. Is that right? No response. That means yes, right? And then most of you pay the way to pay the money is to use what? Credit card. Is that right? Yes. And then okay, so e-commerce company provide the payment process to accept your credit card number and process your credit card and return the process result to your web for your orderly. Is that right? Yes. Okay, so now why I mention this, because when we use the e-commerce system for your payment, that means e-commerce company must use the gateway between you and the e-commerce system. If they don't use gateway, oh, it's very dangerous. It's very dangerous, and for your payment. And if you don't use gateway for the for your payment to e-commerce, and it's very easy for hacker to get in the e-commerce system to get your credit card numbers. Okay, so now you know the gateway is so important, right? And if you still cannot understand what I mean, that's okay, because some of you didn't uh, purchase any e-commerce stuff on the internet, so you don't have any experiences about this. That's okay. Okay, so I give you another example. Another example is you want to transfer your money from your bank by the internet. Okay, by the internet. And that means you need to use your web page to transfer your money and your banking and your banking system. Okay, so the same thing happened to the scenario. Okay, so what does that mean? The banker want to make the money transfer secure. They also need to put the gateway between user, you, and the banking system. Okay, so now you should understand what the gateway is. Okay, so the same scenarios in industry. So we put the gateway in device in this model. So that means we have the IoT data more secure for the communication. Okay, so it's really it should be easy for everyone to understand what the model means. Okay, so question? No? Okay, good. Hold on. Okay, so okay, so the last model right here, backend and the data sharing model. Okay, so the model little bit similar to the second one. The model is the first one, and should be similar to the second one, and a little bit different. Got the more different providers right here, because got the different third party, and the different providers right here, and that means if you got the IoT data in your industry, and you want to share your data to others, and and so sometimes your data might be passed from your device to your provider, and then your provider pays your data to other providers. So, so, so this model happen. That means the IoT data can be shared with other providers. Okay, so however, the first thing need to pay more attention. The providers, those providers cooperate with your providers. Those providers need to be also authorized. Okay, so if not, okay, your IoT data should be very dangerous. Okay, so according to the model and the other provider can view your IoT data and also can share your IoT data. So they can export the data from your they can export the data from your provider, and they also can uh, can 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 use those IoT data from your provider for advanced process and analyze. Okay, so 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 authorized provider should be very important. Okay, so question, no, good. So conclusions for this subtopic. Okay, so they are just so we I provide the four basic model right here for IoT connectivities, not just basic, and those connectivity can be used and connected for devices to produce to transfer the IoT data. Okay, so on the third one right here, the real IoT model should be created based on situation and the requirements a company has. Okay, so depends on uh, depends on what kind of the situation or scenarios a company has. Okay, so additionally, choosing a suitable application type should have the similar scenario. Okay, so suggest depending on requirements and the situation a company has. Okay, so the same idea. Okay, so question so far, no. Okay, we go to next one. Data collection. Okay, so not too many people mention about the data collection in IoT. Okay, so however, we mention IoT data, we need to mention data collection. Data collection. We need to know where the IoT data from. Okay, so now the first page on the subtopic, what's IoT data collection? Maybe the terms is a new one to you. So now we take a look at the first description right here. IoT data collection is process of using sensors to check the condition of physical scene. Okay, so that means data collection, when we use the sensors in IoT, we might produce some data, and depends on what kind of the equipment produced. So we need to collect those data from from those physical objects for future use. for monitor or management. Okay, so second one, why use IoT data collection? So this one is so important, okay, to industry. Every company or industry using IoT needs a robust system for IoT data collection. Okay, so if not, you cannot get the right, correct, and the real-time IoT data. Okay, so second one right here, the data connection process played an important role because it helps you collect real-time, I mentioned just now, real-time data from all of IoT devices, no matter the device is on the remote or on site. Okay, so data collection is so important. So next one, the sensor track the status of the IoT network by creating and transmit real-time data that is stored and retrieved at any moment in time. Okay, we can receive, and the better idea is receive the IoT data in time. Okay, so the purpose is if we can receive the IoT data in time, sometimes we can make some decision and justify something in time that should be okay with our industry management. Okay, so so in real time, it's so important. So the so next one, we present the three types of IoT data collection right here: equipment data, submeter data, environmental data. Okay, so according to the IoT data collection right here, we know the IoT data is various and the variety, and and maybe the IoT data can be produced by sensors produced by various sensors. So we got another IoT data property right here. The property is variety. Okay. Okay. So next one, the first type we want to mention right here is equipment data. Equipment data. So okay. So I got a co-op project with the industry and the company in the past few years, and some of them make a lot of money. However, not all of the company, not all of the department from a company can use the IoT idea inside, and they maybe collect those data and not use the IoT way, and some of them and process those data in their computers and not in the database. I do believe everyone heard the database before. And some of the department in a company I call up I work with I work for my project before, and they use an Excel file for those data from IoT. Okay, so it's kind of it's kind of handy. It's kind of handy, and however, how to say that? Okay, Excel is very Excel is a very smart tool, and uh, however you cannot do the same thing and that DB so so if the data is not if IoT data is not so large, then it should be okay. If IoT data is large, itself file, it's not so it's not so convenient for processing. Uh, uh, okay, sorry about that. For processing, even data analysis, if you want to do the further, processing, like the data mining or the AI things, and the Excel, it, 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 if you use the Excel file in IoT, it's not a good way. It's not a good way. So so uh, uh, I talked to the boss uh, from those companies, and they know the situation. I also talked to the managers from those companies. They also know the thing I mentioned just now. They 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 just don't want to change. The reason is, if they don't want to change, if they want to change, uh, they mm, they must spend a lot of time for something change in OT and the IT. Okay, so they also want to they may also spend a lot of money on the new system and the new equipment. So they haven't changed it. Some of the company they haven't changed it so far. They still use the Excel file for their some system connection. Okay, it's not so good. Not so good. So okay, just a uh, just chat for this page. So we need to talk about the type for equipment data for data creation. Okay, so now the time is 10:28 in Taiwan. So we take a break. Okay, take a 10 minutes break, and after 10 minutes, come back to the meeting. Okay, so 10 minutes break. Okay, thank you.
Okay, thank you, Pokwang. We will break for 15 minutes, I think. Thank you. Hey, good morning, Prof. Wang. Oke, teman-teman dimohon untuk open kamera dulu ya. Kita mau ambil gambar sebentar. Gambar. So please for all students, open your camera. We will take a picture with Prof. Wang. For all students, please open your camera because we need to take a picture.
Assalamualaikum.
Salam. Okay, we start to take picture. In 3, 2, 1. One skin. One skin. Okay, we take again. In 3, 2, 1. Okay. Okay, thank you. Thank you, Prof. Wang. So I think you can continue your lecture.
You're welcome.
Aku sebelumnya.
Okay, back to the talk. Okay, so I paste the hangout to everyone. So if you got a chance to take a look, okay, so keep going. So on this page, we mentioned the first type for data collection. Excuse me. Where is the data from? Okay, so the data, excuse me, the IoT data should be collected from equipments. Okay, so is that so important? Is that so important to IoT? The answer is yes. The answer is yes, because we need to check the excuse me. We need to check the IoT equipment status in time. So we need to know the equipment status. So excuse me. So why the type is called equipment type? Okay, so let us take a look the description on the button. So equipment data can be extended and integrated with production management. Oh, okay. So the same thing. If we don't know the equipment status and we cannot manage those equipment, and if we know the equipment status, we can integrate the equipment status together with material or production management. Okay, so this kind of the data creation is so important and is so useful. Okay, so so the mention excuse me, we mentioned just now, some of the companies still use the Excel, and why don't use the DB? We mentioned the reasons earlier. So what's the difference between the DB and the Excel? Okay, so I give you everyone. Everyone know, because every time I give the lecture to the students about the DB course, and they must ask me the why, and ask me the same question. And actually, when we use the Excel, if we want to access the data from Excel, we cannot guarantee we can access the data from Excel, and those data can be inconsistent. Okay, we cannot guarantee. Okay, so and another major reason is, and search problem in the Excel, we want to search something, something inside the Excel file, you need to search it in sequential. Okay, so however, DB, you don't need to search the data in DB in sequential. Okay, so it's called so convenient. Okay, so because everybody know the idea, and so why the DB cannot be searched in sequential? And because if you search something and in a file or in the DB in sequential, the speed should be not so fast, or not so fast. Especially the situation happened to large records. Okay, so the major reason for DB can use the random access is the DB can produce B plus tree in memory, so they can access data in random, not in sequential. Okay, so we also mentioned some ideas later connect to other subtopic. Okay, so next one. Excuse me. The second one, data creation type is submitter data. Submitter data is we need to correct something. Okay, so let us take a look at the first description. Submittering allow the property owners to automate the measurement of the individual enumerated usage in multi-user setting. Okay, so they can check the measurement for multi-users and what kind of the IoT data can be collected right here. Okay, those data should be like the gas, electricity, water, or cable. And some companies' production is related to this data. And if you can connect this data's information together with production, even to the material, that should be good to management. Okay, so submitter data is also important to industry or company. Okay, next one, the digital submetering devices reduce measurement cost, error, and the improvement timeliness during the bidding process. Okay, so if you have some idea, if a company or industry have an idea to collect submeter data and had better have your environment created in digital submetering environment. And the idea is they can collect those data in time, and the purpose is to reduce the error in time. In case got something wrong with the this equipment, and the manager or the engineer can check those equipment in time. Also, maybe can reduce some costs from industry. Okay, so this is a major idea for the submeter data creation. Okay, so go to next one. Environmental data. Okay, so this kind of the data creation should be familiar with everyone, because everyone should know this one very detailed. Okay, so we need a company maybe need to care about the humidity or temperature or air quality. Also, because some company or industry their material or production might be sensitive to this to humidity, temperature, or air quality. If you know this data's information in time, so you can handle your industry environment in time, and you can control your your environment factor in time. Okay, so it's it's also very important to IoT data creation. IoT data creation, not just from those sensors for companies' production, and maybe those data is created from the environments. Okay, so this is why so important to data creation. Okay, so next one. IoT data creation work. Okay. I use some water. Now on this page, we present the five layers for data creation. Okay, so some people present the 4 layers, and some people present the 6 layers. However, should be the same ideas related to the 5. Okay, let us take a look. Let us take a look at the bottom one. The bottom one is the device layer, and the second one is communication layer, and the third one is the ITH layer, and then next is the event processing layer. Last one is communication layer. And how about which one and which one belongs to OT, and which one belongs to IT. Okay, so the bottom one should belong to OT, and the second one should be the same. And the third one got the IT scene inside, also got the OT scene inside, depends on the company. And the last two depends on the IT technology. IT technology. So go to the next page. Go to the next page. The first layer we called device layer. Device layer. Okay, so in this in the IoT architecture, device that communicate with each other form the primary layer, and this layer is for physical layer, and it's major level for data creation and the data transfer, and so let's take a look right here, and the device there, and some people also say we can we can classify this layers device into four groups. And the first one, UUID, Bluetooth, and the EEPROM, and the beer token, and so why we say so? And the UUID, UUID is a unique ID for ID to identify a device, and some equipment or device need to have the ID. And the Bluetooth is wireless protocol is a way to connect to connect to client, and the master. Okay, so Bluetooth uses his protocol, and the protocol is called Piconet, and the Piconet can be connected to the client and the master. The number of the client and the master is 8. That means the nice people or nice equipment want to connect to the same Bluetooth group cannot get in. The maximum number is the maximum connection is 8. Okay, the third category is the EEPROM. EEPROM is advanced technology compared to ROM. EEPROM can keep the data without any without any electricity, and so data can be read, and also you can rewrite the program inside the ROM. So it's compared to a ROM, this one is more powerful because everyone knows the ROM. Okay, so because everyone got the computers. Okay, and why I say so, and some BIOS need to be embedded in the ROM, so everyone know the ROM, and the last one is beer token. The beer token is a token, is a token that we want to pay the money. We can pay by beer, and can pay by token. It's a smaller one, and it can be used to access objects. For example, on the the picture on the button right here. If you have the token, and you can have the token and get the access and to enter the store, and So this idea can also be used by the IoT. So why device there classify these layers into the four categories. Okay, so so actually this is the basic idea for device there. Okay, next one. The next one is called communication layer. It's called communication layer, and this layer is very, very special. And maybe some of you already implement the idea before. And so let's review the three protocols right here that will be used by this layer. Okay, so the first one, it's text-based protocol. Everybody knows that HTTP and the HTTPS. Okay, so we also know the HTTP use the 80 number 80 port, number 80 port, and the second one, excuse me, some water. The second one called MQTT. MQTT, I do believe some of you already implement this one before, and this one got a lot of the advantage. Okay, so let us take a look at the description right here. MQTT should be similar to the HTTP. It's also a protocol designed to handle embedded system. Okay, optimized to support IoT. Okay, so MQTT is so special. Okay, so compared to HTTP, MQTT super is the super, and it can be run fast and can be run fast. Okay, so however, what differences between MQTT and the HTTP? Okay, let us take a look at the bottom picture. MQTT, if you use the MQTT, your connection need to be open. Your connection need to be open anytime. However, if you use the HTTP, your connection is not necessarily open anytime. Your connection is open on a request, on a HTTP request. Okay, so so the first idea is totally different. The second one, MQTT is a low power consumption. HTTP is a higher power consumption. How about the last one? MQTT send a short message. HTTP not send a short message. Okay, so it's a big, it's the big difference between the two protocols, and you must say, oh, MQTT got so advantages. So any disadvantage or drawback to MQTT? Excuse me. Yes. Okay. So also got some drawback to MQTT. Okay. So the first one I want to mention right here. I just keep the two drawbacks right here. The first one, even it's not so easy to implement MQTT as compared to HTTP. MQTT client, if you want to use the MQTT protocol, the client side must be operated on TCP. On TCP. So, okay, so all is all about the MQTT. How about the COAP? COAP is the last one protocol we want to mention this page and this page. The protocol is based on the
Kenapa, Riz?
semantic, and the pure AP use more space. Okay, so when some protocol or some software use more space. So as compared to MPP, your AP is more difficult to connect by word. And you want to make your IoT data secure, and you also want to connect by word. And you need to pay more attention about the your AP because it's so connect by word. Okay, this all about the three protocols related to there. Okay, so we got a lot of the things to uh need to show. I got a lot of the everyone. So I okay. So next one, ITH there. ITH there. Okay, so on this there, they contact the major thing, physical hardware, software, and the firmware. Okay, so so it seems that we can implement the there in an IT and the OT. Okay, so to look at the second right here, the H there for IoT workflow include the physical hardware of the device and the embedded operating system that manage the process and the device firmware that is software instruction programming onto your IoT device. So depends on okay. So depends on the what kind of the uh, IoT device use. If you can use some of maybe embed some software inside the IoT device, then so you can control the something that is inside. So this though this thing should belong to this there. Okay, so that's one. And okay, it's very important. Okay. We cannot okay. So that's sentence mentioned. This there creates connection with the arm. So this one is very important. The hacker should be anywhere. Hacker should be anywhere. So if you want to if you want you want consider about the security problem and you got the 5 layers right here. The first layer want to consider this there. So you need to make your make the you need to make this layer more secure, and then you can protect your IoT data. So this layer is so important. Next one, event processing layer. Okay, the layer process and the store data created on the IoT device, the second one, maybe some of you already used it before. Okay, let's take a look right here. The event process there can be built by database power, the server side application, the SIs, this server side application tool
Sampai bentar lagi
can be
tutup.
used for can be used can be used by engineers to plot the server side surface. And however, this is just a suggestion. You may ask me, do we use one? The answer is no. The server side got a lot of server side uh, class, and you can use Java, you can use Java, J2EE, J2E, or you can use PHP. However, if you use PHP and your server side, I mean the PHP program, and then if you use the PHP server side, that's the most secure problems on your server side. So this, you find out the security problem, and then you also use PHP, may consider JavaScript instead. Okay, so the same idea implement by banking system. How about the PHP on the server side? Okay, PHP, but no, sorry, how about the Python on the server side? It's not so good, not so good, not so good, not so good. And uh, it's okay with the student structure. Use the Python server side, however, it's not good. The Python on the server side, the problem got the two problems right here: performance problem and the what security problem. And the performance problem. You want to choose the Python or use server side. I suggest you using Java. The reason Java is the good server side stuff, and the Java speed. Java can run fast if as compared to Python. Okay, so even the and however Python get, getting popular the past a few years, and also the Python get some committed was to create what front end. So this is everyone idea. When you use Python, uh, uh, some of you maybe keep up to create front end web application. Don't worry about that. And if you use Knight often, you know Knight is the design code, and you you can. So you want to use the Python to create the web front end, I mean the front end, and you don't need to. It's not necessary for here students to learn HTML, JavaScript, CSS, the stuff. The Python, you just learn the string string STR EAML string package, and you use the package can create a web tool, and together integrate with the Python. Okay, so that's so convenient. However, the scene cannot can cannot persuade you. Also cannot persuade treat the Python server side program program. Okay, so so this okay so next one. Okay, next one. Okay, so you can also create the layer using the IoT cloud service to process all the IoT data. Other processes that occur in this layer. Okay, so something happened. Something also happened to another another subtopic. So the C is do we need to use all IoT data for our IoT process or energy? How about the answer? The answer is no. The answer is no. Okay, so why? Because some of the IoT data, we before we use the IoT data, we to make sure those data is okay with us. So how check the how to check those data? Okay, so we got another subtopic for this. So we go to next one. Oh, spend too much time on this. I spent too much time on this page. Okay, so okay, so okay, so client this layer is client communication layer. So something I mentioned on previous layer, the related client communication layer. When we see the client, the term can connect the term to server. Okay, so when so that means the at the client server side. Okay, so we might have client server architecture. That's right. And then if you get the client server architecture, might have front end and the back end. Okay. Okay. So however, this there focus on the client communication there. The communication there. Okay. So let us take a look on the description right here. Maybe say us time. Okay. 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 On the button. Okay. The this there so the data between the front end and back end. Right. So okay. So actually okay. So how about what does that mean the client communication layer? Okay. So I give you a explanation later. Okay. So make the data inside available to use to IoT system. Store the organized data on the back end. Okay. So okay, I give you a wider explanation. The client side. The client side right here can be web, can be pretty, that can be notebook, that can be cell, can be device, can be device. Okay, so so can be device. Okay, so we need to collect those IoT data on this and then process this. So we created this communication client communication there to take care of this price. Okay, so go to next. Okay, so this is the basic idea. Mentioned just now, the client just I mentioned notebook, cell phone, and computer. We also can put something like the simple chip right here, and that depends on the company. Maybe some of company, some company maybe use the internet for the connection, and some of company might use the internet. Okay, so or some of company might use the other wireless connection. Depends on the company. Okay, so the picture just present the present the client side. Okay, another okay. Next one. Challenges of the IoT data collection. Okay, some of companies, some of companies, some of companies already implement the ideas on this page for their IoT. Okay, so the first one is security. Okay, security is so important. IT also OT. Okay, so so if you want to keep the IoT data safe or in real, in real, so you need to make sure that your IoT data secure. Okay, so how about the second one? The second one, named as the compatibility. Compatibility. So that means, okay, so some tools, some tools IoT cannot some some tools IoT cannot support all of the sensors data. So so we need when we say we are IoT environment, the most compatible our sensor data or not. Okay, so this is so important. Okay, the next one, not data set. We mentioned this one before. IoT data is not. We need to find out the value data inside for our major for our uh, for industry. Oh, consistency. Okay, so when we get the IoT data from industry, we need to measure those data consistent. Okay, so if you cannot measure those data consistent, uh, we we uh, we 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 cannot measure the IoT data can be used by us or not. So according to the ideas on page, we got the two properties right here: veracity and the values for IoT data. So so question. No, okay, go to next. The next subtopic is IoT classification. Okay, so not too many people mention the IoT data classification for IoT. Okay, so now, okay, go to next one. So if you got a company, no, if you work for for a company, so you got some IoT data. So how to put the whole scene, I mean the IoT data, in your system? Okay, I say in your system, before you put your IoT data into your system, you need to store those data in somewhere. Is that right? The answer is okay. So some people say, don't worry, I put those data, I post those data into the what? To the my SQL. You must you must heard my SQL before. And I put those data into the Oracle. Okay, Oracle is the big 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 database as compared to my SQL. Is that right? Yes. And the answer is also because the because the some term inside my test not right, because my SQL and the Oracle belongs to belong database management system, not database. Okay, so once you create the database management system, install first, and then you can create the database by your management system. Okay, so and so the other thing, when we receive the data from the IoT, and those data could be could be could be under different structure, and according to my understanding and my experience, I classify IoT data into three categories. The first one is structured data. Second one is semi-structured. Last one is the unstructured. And then maybe you didn't hear this one before. Maybe you hear this one before. And okay, so uh, I want to give you an overview about this one. That I'm sure. Okay, so however, when you Google something on internet, and then you can find out IoT data. Most of the web mentioned IoT data belong to semi-structured and unstructured. Okay, the unstructured definition is right here because don't have too much time for the detailed which. So if you gotta check right, unstructured right here. So and by a lot of the web say the IoT data belong unstructured and the semi-structured. Because they saw those data, IoT data are complicated, variety. Okay, so however, I don't think so because it depends on the industry. The and if a company use the pure device and the sensor, and the or company the same device to collect some IoT data. And those data, even those data is that. However, it, it's not a variety, not variety. So we want to accept those data. We just use the structured light. Structured light should be okay. Should be, we just use structured light DB accept those data. So according to the free structure, okay, and according to your your experience and my experience, I summarize the idea. If you get the structured data, use the RDB. The RDB is like the database created by the MySQL Oracle progress and maybe everything. No, creating RDB. And if you accept the data from accept the data, and the data is like a semi-structured or unstructured, you choose the NoSQL DB. NoSQL DB. If you use the SQL DB, you cannot accept those data because those data, the format is not fixed. The format is not fixed. Okay, so what are the NoSQL DB? The NoSQL DB, the most popular for for people, MongoDB. Okay, so question, no, it's don't have too much time there. So NoSQL and the SQL key happens right here. And the IoT data can be classified into the three categories, and you need to be careful about the storage that IoT data. If you choose the wrong one for your for you choose the wrong storage for your the wrong DB for your IoT data, or something bad happened to your system. Okay, so for example, you use your MySQL RDB, right, to accept your semi-structured unstructured data, and you cannot even you can accept put those data inside your tables. You cannot measure how many degree of RDB tables normalization should be, and you are going to use higher degree of normalization every this time, and every time you use the the high normalization, then the simple you use it to get more nodes. The nodes means the number of the nodes to join a different tables. Once the situation happens to you, your promote the database performance is going down, very, 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 very fast. Okay, so for the situation, solution is choose non-SQL. Okay, so next one. Okay, it seems we don't have time to introduce the normalization. Okay, I also do believe that some people, most of people use the 4-degree, and the industry uses 3 normal form for the normalization, and the BCNF is higher compared to NF. Okay, so next one, however, this one is for structured data. Structured IoT data. So once you already put your IoT data into your storage, and then you need to know the shape. What does that mean? The shape. You need to know. The data, the IoT data looks like. Okay. So what does that mean? If your IoT data dimension, how big is the 2 dimension? Okay, so and this one is the simple idea, and the second one, how about the data distribution? Okay, so I mentioned that data is not it is not so common to most of people, because the data distribution is the idea from statistics. Okay, so engineers people not familiar with the statistics. However, that's okay if you want to do something about the data analysis and the data cleaning, or you can use some tools like Weka. Weka, Weka, the Weka provides a lot of the statistics to the statistics function inside. You can use that. Okay, so so we need to go to space. Okay, so give me more few minutes. So okay, so on this page means we got the IoT data, and we put the IoT data on our storage. What happened to next? We need to do ETA. We use the ETA for the short. The full name is exploratory data analysis. Okay, so we need to explore the data from IoT. That means that we need to explore the IoT data. Okay, so that means again, I use this step for the for 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 for, for the topic. However, instead, we need to consider data cleaning. What does that mean, data cleaning? When we receive the IoT data, we cannot guarantee all of the IoT data the system can use. No, we need to clean the IoT data. We need to measure the IoT data. Is that okay with our system or not? Is that okay with our system or not? So we need to use some statistic function to measure those things I mentioned just now. So those things will belong to the stage EA. So EA is very, very important for IoT data. So after data storage, so should be the same thing I mentioned just now. I mentioned just now. Second one, we mentioned a lot of things right here. We mentioned a lot of things right here related to IoT, and instead of one thing, we got a lot for IoT here. Speed up the process. We need to speed up the process. And if we don't speed up the process, we may spend a lot of time to process IoT data, and we also cannot get the second response and the feedback to the device or system in time, right? So we need to consider velocity property for IoT data. Okay, so if you consider the 5 properties and the one thing happen, the thing big data. The big data thing contains 5 properties mentioned this topic. Okay, so IoT data example, I give you 3 example right here. The first one, the first one, they use the iPad, they use the iPad to monitor the plan and the farm and by the rules and also collect some IoT data and pay more attention right here. IoT data, not necessarily industry, okay, be anywhere, be anywhere. So the location right here is farm for agriculture. So second one happen to when happen to shift. Okay, so the idea is use the DOM to have the system receive the IoT data and some idea used in the front end. The high technology right here for the front end, the image recognition. The purpose is identify when busy. Okay, so they can after recognize it and pass the corresponding information to backend cloud of server. So this the major idea for example. The third one happen. Third one to happen. The location should be the ship or ship, and they use the tracker to track the ship uh, to track the shipment's location and the condition, and then maybe some shipment uh, uh, is sensitive to temperature. So they work on the temperature. So they try to keep the data from the human location. Okay, so it is kind of the monitor scenes. So next one is the IoT implementation from me. Work with the company. It is the IoT project. Okay. So the company called the A2A Manufacturing Corporation is a company that produces a variety vehicle wheel cover. A vehicle wheel cover can be produced by cover punch machine. So I use the I got the stages right here. The first stage I use the Arduino to test, and the second one I use the WS40. The device is from I purchased device from at the tech company to receive the device information. Those information contain the number of the punching and the punching time, and then I send the information to the parent server together with the other system together. Finally I use the data mining way to analyze and produce workflow for for company. Okay, so this all this IoT project from mine. So the conclusion, data should enable real-time and batch-time analysis of the data generated by IoT data. So we do care about the IoT data today. The predictor is in IT. And okay, this is all my sharing in this talk. In this talk, thank you. Question? No. Okay, thank you.
Thank you, sir. Thank you, Prof. Wang. And now, the session for answer and question. So for all students, we invite you to give some question. Okay. Anyone want to give a question? We have 2 reward for student if you want to make some question. Any question, or you can type your question on the chat box. It's also no problem. Okay, I think there is no question for this session. Before we closing this session, could we take photos? Could we take a photo again in the last session with Prof. Wang? So please, for all students, turn on your camera and we take photo for last time for this session. Okay, Prof. Wang, we will take photo. 3, 2, 1, go. Okay. Okay, Prof. Wang, thank you for your presentation. Thanks for your time to give a lecture in our department, in Information Technology Department. We hope that in the future we can make some collaboration with our lecture or with our student, I think. And once again, thank you very much.
Thank you.
It's my pleasure.
Okay,
Thank you.
Okay, and for all
Thank you.
students, we will continue our lecture on 1 p.m. So in the session 2, we will meet again with another professor from Kunshan University, and we will talking about IoT implementation, Internet of Things implementation, in the 1 p.m. So we will break and we will start again in 1 p.m. Jakarta time or Indonesian time. Thank you, Prof. Wang. Bye bye.
Thank you.
First, okay, first of all is the introduction of IoT. Secondly, we will have the development of IoT. And thirdly, I will talk about the benefits of IoT. And in the fourth, we will talk about the IoT standards and frameworks. Finally, we will talk about some applications of IoT. And I'm not sure we will be able to cover the entire slides, but I would do my best. So we will see how it goes because the slide has 160 pages, and we have around 1 hour and 15 minutes from now, and later we will have our dean of the department will share with you some USR, some application of USR. Okay, and let's begin. Okay, first is the introduction of IoT. I'm sure maybe you already heard some of the introduction in the morning section or with the IoT data, but I will give a very brief introduction first. This is the definition from Wikipedia, the Internet of Things. The Internet of Things, or in short, IoT, I from Internet, O from off, and things from T from things, describe physical objects. Let me see. I can guess. See. Okay. The Internet of Things describe physical objects or group of such objects with sensors. So the keyword here is sensors. We need to have some sensors. For instance, like the phone, we have the phone here. We have a lot of sensors, the 3G sensors, a G4 sensor, and some the camera sensor as well. And we have all devices with sensors and with the processing ability. It's important to for the IoT devices to have the processing ability because you need to process some data and you need to transfer some data as well. So you need to have some processing ability with the devices, and the software is required, and some other technologies that connect and exchange data. So we need to connect and exchange data with other devices. So the communication is important among IoT devices because all the information or data need to be exchanged among the devices. And those communication usually will take place at the internet or other communication network. Okay, so we will talk about some of the communication network later. So that's a very brief definition. I'm not sure you already watched this or not. I put several videos from the YouTube and talk about what is IoT, and maybe we can watch one of them.
The Internet of Things, or IoT, is a system of connected devices, computers, and digital machines with unique identifiers that transfer data over a network. Smartphones, laptops, wearables, sensors, they're all part of the Internet of Things as long as they're connected and sharing data. Beyond that, IoT also includes a person with a heart monitor implant, a farm animal with a chip transponder, or a car alerting a driver to low tire pressure. In a business sense, IoT supports smarter working with more control. Across industries, IoT enables process automation, analysis and insight, labor reduction, and performance monitoring. For example, airlines use IoT sensors.
Sorry.
Devices, computers, and digital machines with unique identifiers that transfer data over a network. Smartphones, laptops, wearables, sensors, they're all part of the Internet of Things as long as they're connected and sharing data. Beyond that, IoT also includes a person with a heart monitor implant, a farm animal with a chip transponder, or a car alerting a driver to low tire pressure. In a business sense, IoT supports smarter working with more control. Across industries, IoT enables process automation, analysis and insight, labor reduction, and performance monitoring. For example, airlines use IoT sensors for real-time data reporting on airplane engine status and equipment conditions. Theme parks even use IoT to track visitor movement for insight into popular attractions and traffic flow. This can help the park better address bottlenecks, long lines, and even waste management. Businesses are increasingly adopting IoT to improve efficiency, customer service, and decision-making. But all these connected devices are not without potential issues. As the number of connected devices and shared information increases, so do security and privacy concerns. Also, any bugs in a single device can potentially affect an entire IoT system. In addition, and this is true especially for an enterprise, these connected devices produce a ton of data, which can be difficult to collect and manage, let alone glean business insight from. Finally, competing IoT standards can create headaches in terms of getting different devices from different manufacturers to communicate with one another. Still, companies will have to address these challenges because the IoT market is booming, and experts predict IoT adoption and spending will grow exponentially over the next few years.
Okay, that's a video of what is IoT, and we have seen several important issues, some advantage of IoT, disadvantage of IoT, and some the concern. And IoT is growing rapidly in recently. So jump to the next page. Okay, there's another video. I will not watch this one, but you may find out some of the information, the IoT Internet of Things from the YouTube. So here's another one. Here's another one. Okay, we will use this information from this web to talk about what is IoT and talk about more of IoT. The Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines and objects, and animals or people that are provided with a unique identifier. We will call that UIDs. The unique identifier is important with the IoT field because you need to have an identifier. It's very similar to the IP address to the computer or to the any notebook or any devices that connect to the internet. In the IoT network, you still need to provide some unique identifier so that other devices can communicate with you through the unique identifier. So that gives the IoT devices the ability to transfer data over the network without, here the keyword here is the without requiring human to human or human to computer interaction. So with the IoT infrastructure, you can eliminate as much as the human intervention. So you don't have to have a human to be in charge of any communication. When we talk about IoT, the things, Internet of Things, a thing in the Internet of Things can be a person or with a heart monitor implant, or a farm animal, a cow, or a farm animal with a biochip transponder, or automobile that has a built-in sensors to alert the driver when the tire pressure is low, or any other natural or man-made object that can be assigned an IP address that is able to transfer data over a network. So some of the IoT devices look like this. Some are sensors, some are the buttons, and some are the built-in sensors for other purpose. And increasingly, organizations in a variety of industry are using IoT. So it's not a surprise now. IoT has been very used increasingly in a variety of industries to operate more efficiently and to better understand customer, to deliver enhanced customer service, and also to improve the decision making and increase the volume of the business. Next, we'll talk about the IoT architecture. The IoT architecture can be divided into 3 layers. The bottom layer is called physical layer. The physical layer is made up of devices, sensors, and controllers. They are what make the IoT environment. And the devices may be like the smartphones or some tablets or laptops, and devices with microchip or brownfield devices with RFID tags. The second layer is edge computing layer. It's right between the physical there. So the bottom is physical there, and the top is cloud or data center. And on top will be the application layer. We will talk next. And in between the physical layer and the cloud, we have the edge computing layer. Edge computing layer is for the purpose to store and process data near the devices, where it is generated rather than the servers located far away. Is called edge computing. So before we have the edge computing layer, usually the data will be transferred directly to the cloud. But with the edge computing process, you can do some data management or data collecting process and do some data pre-processing before you transfer back to the cloud server or data center. So that's the purpose of the edge computing, is to store and to process data nearby the devices. And the edge computing layer defines the network and communication protocol to be used for connectivity as well as the edge computing. The processing of IoT data starts at the edge of the network. So that means the processing of IoT data, instead of starting from the cloud, actually it starts from at the edge of the nearby the physical devices. Okay. Any questions so far? Okay. Okay. Next one, we'll talk about the application layer. Application layer is the layer that most close to the user, and the devices are with the sensors reside within the cars, within the person, or like cell phones. Those are devices. Those are the physical layer. And we just talk about the edge computing layer in between. And we have some connectivity, and those connectivity will transfer data to our storage or to our server. So beyond the edge computing layer, we will transfer data to the cloud. The application layer is a set of integrated services provided by the IoT cloud. So IoT cloud will provide the services. So these are the services provided by the IoT cloud. So user can access those services and can provide and can get the information from the storage. So the data is from the physical devices. So the physical devices will transfer data through some gateway here, and with one kind of communication protocol and to the storage. So user can have a request for the data, and the data will be transferred to the application layer for display. So the data generated by the IoT devices is clean and relevant data stored on cloud servers for further processing to generate some report and insight. So the data is so important with IoT, with different layers of IoT. And finally, the data will be transferred to the cloud server, and the cloud server will do some further processing of the data to generate some report, some business report, some insight of those data to find out is there any problems with production, with manufacturing, with supply chain, etc. So they will make decisions according to those reports and insights. Businesses can get their own customized applications developed on top of the tools provided by the cloud server providers. So the cloud server provider can provide some services to the company, to the enterprise, and they can build customized applications on top of those tools. So it's more flexible and it's more efficient to it's a more efficient way to generate or to build some customized applications to users. Okay. Once an IoT ecosystem is set up, new devices continue to get added to its as per requirement. So once you have the IoT ecosystem set up, you can add home devices, some other different devices from over the network to the existing IoT ecosystem. So the network should be scalable quickly so that it can handle the surge of the connected devices. So the requirement for the network of the application layer need to have the scalability that the new devices can be added quickly to the existing IoT ecosystem. Next, the application there, we talk about some of the protocols. We will use some of the protocols. Those protocols is in charge of the communication, like ZB or Z-Wave. You all heard about the Wi-Fi or Li-Fi or NFC, 5G, Bluetooth low energy, or some other type of communication protocols as well. Okay, we finished the IoT architecture. Next, we will talk about how does IoT work. An IoT ecosystem consists of web-enabled smart devices that use embedded systems such as processors, sensors, and communication hardware to collect, to send, and act on data they required from their environment. The IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge devices where the data is either sent to the cloud to be analyzed or analyzed locally. Sometimes these devices communicate with other related devices and act on the information they get from one another. The devices do most of the work without human intervention. Although people can interact with the devices, for instance, to set up the devices or to give them instruction or to access the data. The connectivity, networking, and communication protocol used with these web-enabled devices largely depend on specific IoT application deployed. IoT can also make use of artificial intelligence and machine learning to add in making data collecting process easier and more dynamic. So we will see that artificial intelligence and machine learning can help a lot at data management and data processing with the IoT. This diagram is an example of an IoT system. The IoT devices, that, for example, like sensor, antenna, microcontroller from different IoT devices with different sensors. First step is to collect the data. And through the IoT hub or through the IoT gateway, they collect and transfer data through IoT hub or gateway. And then finally, They can analyze data to take the action, whether the user interface with a smartphone or analytic of a business application, like customer relation management, ERP, and backend systems as well. So that's how the data are being collected and being transferred and being analyzed. So that's how the data among the different IoT frameworks are doing, and that's how IoT works. The Internet of Things helps people live and work smarter. So we use the word here, smarter, because we provide more efficient way or the smarter way for the users that they can monitor the environment more wisely, and as well as gain complete control over their lives. In addition to offering smart devices to automate homes or IoT is essential to business. IoT provide business in a real-time look into how their systems really work, delivering insight into everything from the performance of the machines to supply chain and logistic operations. IoT also enable companies to automate processes and reduce labor costs. So that's one of the importance and one of the benefits that to use IoT to reduce the labor costs. It also cuts down on waste and improve the service delivery, making it less expensive to manufacture and deliver goods. So that's also to save money because it reduces the cost of manufacturing. Also, IoT is one of the most important technologies of everyday life as it continues to pick up steam as more and more businesses realize the potential of connected devices to keep them competitive. So a lot of industry or companies, they start to realize that how important to have those connected IoT devices to help their manufacturing or their supply chain or their delivery of goods, everything. So that's a very important technologies nowadays for many companies. Okay, so we finished the first section of introduction of IoT. I will just pause a little bit and see if we have any questions.
Okay, for all students, if you want to ask question, you can directly speak on the mic. Anyone want to give a question?
Excuse me, can I ask something?
Okay, Nazila. Okay. Okay, please give us your question directly.
Okay, thank you for. I want to ask a little about IoT. In your opinion, how important is IoT in the development of the world in the future?
Okay, so the question is how important of the IoT and for the development in the future.
Yes.
Okay. Okay, that's a very good question, and it's very important, and we will talk about as we go on to the talk. We will talk about the more importance, but I will give a very brief opinion of that's my personal opinion, because the smartphones is one of the most available devices of IoT. So usually we don't think the smartphone or those wearable devices like Apple Watch, those wearable devices, they are part of the IoT. But usually when we talk about IoT, we will think about those IoT in the big company or in the manufacturing, in the factory use. So those will be industrial IoT. However, since more and more devices like smartphones and wearable devices are available, and especially young people, they like students like you are getting used to the devices, the wearable devices with the Apple Watch or some other devices that can record your heart rate or everything to monitor your physical health. So those kind of devices has been used more and more recently. So I'm sure the future of IoT will keep growing in different kind of in all businesses, in different fields, in different industry. And I just give you an example that right now it's in pandemic, right? And with the COVID-19, the pandemic, and people are panic. So like in Taiwan, all the citizens are quite nervous and anxious about the pandemic and the spread of the virus. And IoT also, in order to deal with these kind of issues, the IoT can play important role there. For instance, the sensors of IoT can monitor how crowded of market of certain area of the park. It can monitor how many people are there. So that can tell. Then you can get the number from your phone or from the other devices to know that, oh, okay, I think the park there is too crowded to go to the park because it's too crowded. So that's another way to use of the IoT, because you can use those devices and to generate to collect the data of the people, how many people, the crowd. And also in the future, IoT can be used along with the 5G, the 5G communication of I'm not sure you heard about the 5G recently, because right now the communication, the telecompany primarily using 4G communication to your cell phone. However, in the future, the 5G technology will get more popular and more mature in the future, and that will help. That will increase the use of IoT application in smart cities with self-driving cars. The cars can communicate with each other. Right now, the car we have, they are not communicating with each other. they are just showing some information of the car itself. It doesn't tell you how many traffic lights ahead of the car, or how crowded of the traffic nearby. So in order to get to your destination, in the future, the IoT with the smart city implementation, the IoT can provide information of the traffic in the city, and those information can provide a useful and efficient way for the drivers to get to their destination. Okay, I hope that answered your question.
Okay, thank you, Prof. Lee.
Yes, thank you very much, sir.
Okay, okay. The another question.
Yes, I am
Because-
May I?
I have a
Okay,
question.
okay.
Hello,
We have many
sir.
questions. I think Prof. Lee, you can choose the question from the student.
Oh, okay.
So you choose, okay? Okay.
Let me see.
This one, do you want, Prof. Lee?
Which question I cannot see?
I mean, there are many people that they want to give you the question, but I mean, could you choose the question? Could you choose the student? Which one that do you want to answer? There are down. Okay.
Okay. Go ahead and ask.
Okay, I think I will choose from Angga. From Angga, I think. Angga.
Okay. Thank you for the opportunity, sir.
Okay, okay, directly.
Okay. Can you hear me?
Yes, yes.
Okay. I have two questions from the last explanation. The first question is, I would like to ask about predictive maintenance of IoT. And the second question is, we all know that IoT security is still lacking. So is there any solution for that security problem?
Okay. Can you repeat the question again? What's the first question?
Okay. The first question is, I would like to ask about predictive maintenance because in the last explanation, you mentioned about the predictive maintenance of IoT. And the second question is, we all know that IoT security is still lacking. So is there any solution for that security problem, sir?
Okay. The second question I got your second question is security, right? The security, you want to ask if there any solution to the IoT security, right? Is that the second question?
Exactly.
Okay. I still didn't get the keyword of the first question. Would you mind type at the chat what's the keyword of the first question you want to ask?
Predictive maintenance, sir. Predictive maintenance of IoT.
Oh, the maintenance of IoT.
Predictive maintenance, sir. Predictive maintenance. Predictive maintenance.
Private maintenance.
Predictive.
Predictive maintenance, sir.
Predictive maintenance. Okay. Predictive maintenance. When you talk about when you mention predictive maintenance, are you referring to the machines? The machine maintenance?
Yes, this
Yeah.
in machine, in industrial machines, I think.
Oh,
Exactly.
okay. Okay, I got it. Thank you. For the manufacturing company, do you know CNC machine?
Of
Yes,
course.
yes, we know. Yeah.
Okay. From the manufacturing, there are CNC machines, and those CNC machines, they need to usually now they need to have certain IoT devices like sensors to detect the vibration, and those vibration data will be collected through those IoT devices. And those IoT devices will transfer those data through the IoT gateway or IoT network to the server nearby. And the server will collect the data of the vibration of the machine. So as you get more and you collect more and more data of the CNC machine, of the vibration, then you can learn that when is the best time to replace some of the parts. So that will be one example of the predictive maintenance. Is that clear of the predictive maintenance?
I think that's enough, sir.
Okay, that's one example, but predictive maintenance is always challenging. The example I gave you is a very simple one, and is the most people have solution for that already. So it's nothing new. But if your machine is more complex, is more complicated, it's a large machine with multiple parts, it's getting more difficult to do the predictive maintenance, because there are different parts, and different parts can break in different reasons. So you need to have a different sensors or different devices to detect those problems in advance.
Okay, thank you, Prof. Lee.
Okay.
And
Okay,
the
that's
next one. Okay.
right. That's the first question, and the second question I will give a very brief, quick question, quick answer to the security solution with the IoT. Actually, besides you increase, usually the problem is with the communication, and with the IoT devices. Actually is a computer, but for your personal computer, you will install the antivirus software. But usually for the IoT devices, we think, oh, it's a small device. It's just transferring data. It's not doing something very advanced. And also IoT devices usually are very cheap. So it's like maybe 10 US dollar per device. So you probably don't want to invent like 100 US dollar of antivirus software to the devices. So that's why it caused some security, increased some security issue, because those IoT devices are not secure. They are not secure enough. So actually the solution shouldn't be too hard. The solution you apply to your personal computer, to your servers, can also, those solutions, some of the solution can apply to the IoT security as well. Okay.
Okay, I think it's clear, right?
Yeah. Thank
Okay,
you for the great answer and opportunity, sir.
Thank you for your great answer. Great question.
yeah, we have to question the another question from Nur Khalifa.
Okay. Yes.
I think my question like slightly off the topic. So as we know, there's a new Nobel in 2022 about quantum entanglement. And my question is, IoT same as quantum entanglement, then will IoT disappear as quantum entanglement develop? Because I
Okay.
think quantum entanglement is better than IoT. Thank you.
I see. That's a good question. I never thought about that, but in my opinion, the IoT can work well with other technologies like quantum technologies. I don't think any technology will replace IoT completely, because let me ask you a question. Do you think smartphone is an IoT device?
I think yes.
Okay. And do you think in 10 years the smartphone will be completely disappear?
I don't know because I don't know the answer. So I asked to you.
Right. So I don't think the smartphone will disappear. So that's why I don't think IoT will be disappear completely. So other technologies like, for example, like we talk about artificial intelligence, deep learning, quantum computing, edge computing, etc. All those technology are helping IoT to get better. That's my opinion. Does that answer your question?
Okay, I think it's clear, Nur Khalifa. So we can next to the last question from Putri. Putri, give me your question.
Okay. Hello, sir. I want to ask about IoT. If many industry use IoT, it will make the industry operating system more efficient. But what
Actually, in many years ago, when we have the automation, of the manufacturing, we will think that those automation will replace all the human labor. However, it doesn't replace completely. So the human will do more advanced work. So I don't think IoT will replace IoT itself doesn't provide the labor. Actually, your question should refer or may refer to the robots. So of course, robots has a lot of IoT sensors on the robots in order for the robots to work. The robot will help the manufacturing, that's for sure. But the IoT itself, it only provide more information to the workers. So I don't think the IoT will replace the labors completely.
Okay, thank you, sir.
Okay, thank you.
Okay, thank you, Prof. Lee. I think for question is enough.
Okay.
So could you continue your material?
Okay.
Okay.
Thank you. Okay. We continue with the development of IoT. First, those are very good questions from you. I just give you the introduction of IoT, and you already can ask so many good questions. Some of them I never thought of those questions before. So appreciate those questions, and feel free to write some questions to ask later. Okay, let's move on. Okay, maybe you already know some of the history. I just give you a brief history from in the past. In 1969, we have the ARPANET. That's the first, the precursor to the internet is being developed in 1969. And let's talk about that. When we talk about the IoT, the first I refer to the internet. So in 1969, we have this ARPANET. This is developed from the U.S. Defense Advanced Research Project Agency. And also this is the foundational to the internet, part of the IoT. Okay, that's the, in 1973, that's the geographic map for the ARPANET. So ARPANET was the first connected network granted of the internet as we know it today. So that's the history of IoT starts with ARPANET. Okay, so I think we don't have any doubts or any questions of that, because the history of the internet is also the history of the Internet of Things. Okay, the very beginning. So we need to have the internet first. The internet history of 1970s, we will not go into the detail. Just the nodes are added to the ARPANET at the rate of 1 per month. So the increase of the nodes are slowly in the beginning in the 1970s, and those are some. We have more and more nodes are being added to the ARPANET, and by the 1971, the ARPANET has 14 nodes in the operation. So that's the ARPANET map in 1971. And the network working group completes the telnet protocol and makes progress on the file transfer protocol FTP. So at the end of the year, the ARPANET contains 19 nodes. Okay. And what's this? And here, the Larry Roberts and Bob Ken decide that this is time for a public demonstration of the ARPANET. So that's in 1972. In 1975, January, the ARPANET network contains 61 nodes. Okay, that's 1975. So the network keep growing and growing, and we have the 6 other universities discuss the possibilities of building a computer science research network to call the CSNet. Okay, so we have more and more network. And in 1980s, ARPANET is opened up to the public by commercial providers, making it possible for people to connect things if they want to. And that's some history diagram there. There are the telnet-based system with the ARPANET. And that's the first IBM PC. The IBM PC is launched in August 1981. It's called Aspen. So Aspen 1 was the first introduced in 1981. And by the beginning of the year, more than 200 computers in dozens of institutions have been connected in CSNet. In January in 1983, the ARPANET standardized on the TCP/IP protocol adopted by the Department of Defense, and the Defense Communication Agency decided to split the network into a public ARPANET and a classified military net. Okay, with only 45 hosts remaining on the ARPANET. Okay, the newly developed DNS is introduced across the internet, and with the now familiar domains like .gov, .military, or .edu, .org, .net, and .com. Those all started from the same year. And here is the map of NSF net backbone. There's a NSF net. So there are more and more network. So between the beginning of 1986 and the end of 1987, the number of networks grows from 2,000 to nearly 30,000. So that's quite a large increase from 1986 to 1987. In 1987, we have the internet map. So we have the ARPANET there, and we have the military net, NSF backbone, and others. So we finish this part, and we see the history of the internet. So we will see the next important invention is the vending machine. It's a Coke vending machine. In 1982, programmers at Carnegie Mellon University built a vending machine to connect a Coca-Cola vending machine to the internet. So that might later we think this is the first IoT device, because that's a vending machine and they connect it to the internet. So it's a vending machine, and usually the inventor is David Nicholas. In 1982, is a graduate student in Carnegie Mellon University, CMU. He's in computer science department, and usually the vending machine is far away from the department, so he needs to go to the vending machine to check if there is a code Coca-Cola there. However, it takes a while, so he think about the idea of putting the information of this vending machine to the internet, so that he can avoid walking the distance to the vending machine, and he can get the how many code Coca-Cola is available at the vending machine. So he can check that from the internet. So in 1983, that's a modified Coca-Cola vending machine at CMU become the first internet connected device. Okay, and the code they wrote could check if the Coke was available in the vending machine, and if yes, whether it was code or not. So anyone on the university ARPANET could monitor the status of the Coke vending machine. So that's what quite achievement in 1982. They have the first device, the first IoT device, which is a device, a vending machine connect to the ARPANET. In 1989, Tim Berners-Lee proposed the framework of a World Wide Web, the foundation of the internet now. Okay, and next we will talk about another great inventor is the toaster. The toaster is the first toaster to control via the internet. So in 1990, John Rumke is response to a challenge to connect it toaster to the internet. So that's we will think that's a modern IoT device because we can control the toaster. So that's the first smart toaster that the first IoT device that can control with the internet. There's no Wi-Fi lane, so at that time in 1989, in 1990s, there's no Wi-Fi, so there's only the ARPANET. Okay, in 1993, engineers at the University of Cambridge upholding the now well-established tradition of combining the internet with appliance and food, and develop a system that takes pictures of a coffee machine 3 times a minute. So that will be, we consider that the world first webcam. So that's we'll skip some of the detailed information. In 1993, we have the first webcam. In 1995, the GPS satellite network is complete. The long-running GPS satellite program and can provide the location to you. And in 1998, we have IPv6 protocol. Enable more devices because IPv4 can only provide 4.3 billion devices. However, we need to, with the more and more devices are requiring the IP address, so IPv6 become a draft standard and enable more devices to connect to the internet. So that's a very large number because it's 128 bits. Okay. In 1999, the term Internet of Things is first used by Kevin Austin of MIT. This is the 1999 is a big year for IoT. Since this phrase IoT Internet of Things was provided first, used by Calvin Austin, the head of MIT's Auto ID Labs. Okay, so later is a potential of RFID tracking technology. So that's RFID in 1999, the next milestone of development of IoT. And in 2004, the phrase IoT, Internet of Things, start popping up in books, titles, and media appearance, so getting more and more popular. The term IoT began to be used in mainstream publications like the Guardian and Scientific American by 2003 and 2004. In the same period, RFID deployed by U.S. Department of Defense here and by Walmart in its store with RFID. Okay, in 2005, the United Nations International Telecommunication Unit acknowledged the impact of IoT in its report. It predicts that IoT will help create an entirely new dynamic network of the networks. Okay, next, 2007, we have the first iPhone. The first iPhone is released in 2007. So when I mentioned about the beginning of this talk, I asked you whether you think a smartphone is an IoT device, and actually it is. So in the history, in the timeline of the major events in IoT, smartphone is a very important invention, And the first iPhone is appear at the year of 2007. Appear on the scene, offering a whole new way for a general public to interact with the world and the internet connected devices. So all the devices like smartphones are connected to the internet from different network. And in 2008, we have the first international IoT conferences. Okay, that is held in Zurich, Switzerland. The year is fitting, etc. So that's a very big thing in 2008. And in 2009, Google started testing self-driving cars. In 2009, Google started testing self-driving cars. And in 2010, Chinese government names IoT as the key technology. And Nest is a company with a smart thermostat, also putting the smart home concept in the spotlight. In 2011, Gartner, the market research firm Gartner, adds IoT to their hype cycle to measure the popularity of a technology. So that means IoT is a very popular technology in 2011. In this Cisco Internet Business Solution Group, in its 2011 white paper said, Internet of Things can truly be said to be born between 2008 and 2009. Okay, in 2013, we have Google Glass, that's IoT and wearable technology. And Amazon 2014 release Echo. It's a way to connect to increase the smartphone and to increase the supply chain process and the manufacturing. In 2016, General Motors, Tesla, Uber are all testing self-driving cars. Unfortunately, the first massive IoT malware attack is also confirmed. So that's the question regarding with the security of the IoT devices, because it's under it's under the DDoS popular DDoS attack. In 2017 to 2019, IoT development gets cheaper, easier, and more broadly accepted, leading to a small waves of innovation of all over the industry. And self-driving cars continue to improve, and blockchains and AI begin to integrate it into the IoT platforms. And increased smartphones and broadband penetration continue to make IoT an attractive proposition for the future. So the future of IoT technologies like AI and blockchains are increasingly being used to make our device more independent and better network. And the rise of the edge computing is largely driven by the realization that the proliferation of IoT devices. And so the privacy and security issues that will draw our attention. Okay. I think that's good. Good place to stop. I will open to the questions.
Okay, any question from students? You can type on the chat box also, it's no problem. Okay, I think nothing question, Prof.
Okay.
So good. You can continue.
Okay. And next, sorry. Okay, let's move on. Next, we will talk about the benefits of IoT. So the benefits are first, can monitor all overall business processes. That's the first thing, is to monitor the overall business processes. And second, to improve the customer experience. And third is to save time and money, because you have IoT to help save the time and money. So time is money. So it's important to, if you can get your manufacturing more efficient or your delivery more efficient, then you save time. And once you save time, you can save money. And also enhance the employee productivity with IoT. And also integrate and adopt business models. And with IoT, and you can integrate and adopt different business models and to help your business growth. Also, you can make a better business decision according to the data and to the report of the data collected from the IoT devices, can get the business insight in different in making better business decisions. Also, you can generate more revenue because you make better business decisions, so you can generate more revenue. And IoT encourages companies to rethink the ways they approach their businesses and give them the tools to improve their business strategies. So that's the advantage of IoT, the benefits. IoT is the most abundant in manufacturing, transportation, utility organizations, and making use of the sensors and other IoT devices. Some use cases for organizations within agriculture and infrastructure and home automation industries. IoT can benefit farmers. In agriculture by making their job easier. Like the sensors in the greenhouse can detect the information, the humidity, etc., transferred to gateway through the IoT network and to the farmer. That's the application. And the sensors can collect data from on the rainfall, humidity, temperature, and soil content, as well as other factors that will help to automate the farming technologies. Also, another benefit is to monitor operations surrounding the infrastructure. Is also a factor that IoT can help with. Sensors, for example, could be used to monitor events or changes within structural buildings or bridges and other infrastructure. And home automation business can utilize IoT. With the home, we have a smart TV with wireless speaker, cell phone, wireless headphones, tablets, Wi-Fi routers, laptop, wireless mouse, all smart technologies like lighting, and wearable wireless MP3 player, wearable watch, other controller, wireless keyboard, etc., all connect to the cell towers, etc. So home automation business can utilize IoT to monitor and manipulate many mechanical and electronic system in a building. Okay, on a broader scale, is a smart city. Smart city can help citizens to reduce waste and energy consumption. And IoT touches every industry, including business within healthcare, finance, retail, and manufacturing. So we have the health part, healthcare, finance, retail, manufacturing. here are some of the advantage of IoT. Ability to access information from anywhere at any time on any device. Some of the advantage, another advantage is improved communication between connected electronic devices and transfer data packets over a connected network, saving time and money. So that's a connected network. Is transferring data over a connected network, saving time and money. Also the automating tasks can help improve the quality of the business services and reduce the need for human intervention. And also that will increase the revenue because you get a more efficient way of production. Okay, we talk about disadvantage. One of the disadvantages is a hacker. Hacker could steal confidential information. And also with a massive number of IoT devices, so it's hard to collect and manage data from all these devices will be getting more and more challenging. And another way is a bug in the system is likely that every connected devices will be corrupted. So one bug in one system, so maybe one bug here can affect the whole entire system because it's all connected. So it's all connected devices. So there's no international standard for competitivity of for IoT. And the security and privacy issue, IoT connects billion of devices to the internet and involve a billion of data points, and which need to be secured. So due to the expanded attack surface, IoT security and IoT privacy are cited as a major concern. So maybe in the future, if you want to focus on the project of IoT with the company, you need to take security and privacy issue seriously because it's getting more and more secure, more critical and more important to the company. In 2016, one of the most notorious recent IoT attack was Mirai. It's a botnet that infiltrated domain name services provided by DIN and took down many websites for extended period of time. It's one of the biggest DDoS attack ever seen. So attackers gain access to the network by exploiting poorly secured IoT devices. So the IoT devices need to be secured in order to prevent this kind of attack. So because IoT devices are closely connected, so you need to increase the security. Otherwise, you will leave the vulnerability for the cyber criminals. And also, connected devices often ask users to input their personal information. So information that is invariable to the hackers. Hackers are not the only threat to the Internet of Things. Privacy is another major concern of IoT users because they can sell your users' personal data. Okay, that's it for the benefit. Let me see if I think I still have more slides. The IoT standards and frameworks. We have the IPv6 and ZB. Those are the frameworks. Light OS, 1M2M, data distribution services and object management group, and some other advanced message queuing protocol, AMQP, and also with COAP, constrained application protocol, and long-range wide area network, LoRa WAN. That's for smart cities, millions of low power devices. And we have Amazon Web Services IoT is released by Amazon, and ARM IoT is ARM microcontroller, and we have Microsoft Azure IoT. We have Google Android-based OS Wave and IoT oriented communication protocol. Calvin is an open source IoT platform released by Ericsson, the telephone company. Lastly is the enterprise IoT applications. I'll quickly go through those. We have manufacturing and industrial IoT, automated telecom and energy company will use them. Smartphones, smart homes is another application. Wearable devices with sensors and software can collect and analyze user data. Wearable devices are also used for public safety as well. In healthcare, we can have IoT offer many benefits. Smart buildings, for instance, reduce energy costs using sensors that detect how many occupants are in a room. In a smart city, sensors and deployments such as smart streetlights and smart meters can also help to increase the efficiency of the energy. Economic impact of IoT, you can see in 2025, 11.2 trillion value. Can force COVID-19 pandemic has forced rapid adoption of IoT, and we have some of the challenges of IoT will be the hardware challenging, the data planning challenging, privacy and security challenging. We talk about sustainability. All IoT devices need to be powered on 24/7, so you need to have reliable powering to have a sustainability. That's technologies that have supported IoT growth. We have cloud computing, big data, artificial intelligence, availability of chip storage on cloud, enable business to store a massive amount of data generated by IoT systems at an affordable rate. So that's very important to have a cheap cloud storage. And big data technologies have made it easier to organize and make sense of data generated by IoT. Artificial intelligence and its associated technologies have enabled to generation of insight that helps business grow. Regulation, the government regulation is frowned upon by the developers and technologies enthusiastic. Government across the globe have taken notes of this and are issuing their own guidelines for IoT adoption. And there are some examples in Australia and UK. And in 2020, January, California and Oregon in the US, also they require the responsible security features to be added to the IoT devices to increase the security. According to state, by 2025, the value, the installed devices will exceed 75.4 billion globally by 2025. And finally, the future of IoT, the 5G integration. IoT architecture will be integrated 5G into its system, single interface, and multi-level privacy and security. Data privacy and security is going to be even more important. In the future, the privacy and security measures will be implemented at the multiple layers between IoT endpoints. the shift from products to services ecosystem, the key driver of any IoT system is the data generated by it. So data is the key driver for any IoT system. Across the globe, security regulations are being drafted to the data privacy and security can be ensured. Okay, and the rapid growth of IoT has been supported by cloud computing, 5G, and artificial intelligence. Okay, thank you very much for this talk, and I'm not sure we have time for any questions.
Okay, thank you, Prof. Lee. Before we closing for your session, we need to take a picture with our student. So
Sure.
please, for all students, could you turn on your webcam so we can take. And welcome also for Prof. Chang. Good afternoon, sir.
Yes.
So yeah,
Okay.
so we need to take a picture before your session, I think. Okay, I will take a picture. I will counting for 3, 2, 1, and okay, thank you. So any question for Prof. Lee for his topic before we closing for session for Prof. Lee? Okay, I think it's enough. Thank you very much for Prof. Lee for your presentation and your material. We hope that in the future we can make some collaboration with our lecture and our student. Thank you.
Okay, thank you for inviting me, and I have a great time share IoT with all of you. Thank you very much. Thank you, Professor. Thank you.
You are welcome, sir.
Thank you.
Okay, so and the last session is the presentation from Prof. Qingpao Chang from Gunsan University. The professor will present it about his project, IoT project, implementation of IoT in his project. So for Prof. Chang, time is yours.
Yes. So I need to share my PowerPoint.
Yes, but the sound is not the volume. The volume is you need to increase your volume, I think. Okay, it's
Okay,
clear.
can you see my screen?
Yes, yes, sir, it's clear. Please.
Okay. In the last section, I will spend a couple of minutes to share an experience in the IoT that's apply IoT technology in agriculture. So this is my guideline. I will speak the background. This project is posed by the Kunsan University Higher Education Sprout project, and the best idea for this project is to apply the IoT on the farmer to increase the management performance. For example, this is the basic architecture of our project. The first one, this one is the data collection module, and this one is the sensor node. There are several sensor nodes will send the data to the data collection module, and then the data collection module will transmit the data to the remote cloud server by the HTTP. So this one is the cloud server. And because the data sent to the cloud server, and we can use the data to modeling to generate models, and then we can make a prediction for the data and make a decision. The decision will send to the sensor and control the device, make maybe some control, maybe use the regulation or something. Okay, so this one is my architecture framework. So the best idea is to collect data to construct the farm name soil moisture model. The soil moisture, you want to know the water the water loss in the farm, and we can create a soil moisture model and make a prediction when we need to make irrigation to put water into the farmer. Okay, this is the detail of our architecture. This one is the data collection modules, and this one is the sensor module. The sensor module, we have a sensor, and then we have a data transmission unit, and then we have a control unit here. This one is the sensor node. There are many sensor nodes that connect to the data collection modules. The data collection module will gather all the data and then transmit the data to the remote site. The remote site, we have a database, and we have maybe the data analysis API and data analysis the module, and we can use the collected data to make a model. And then on the next time the data goes to here, and we can use the model to make a prediction and then make a decision and send to the sensor node. This is our product. This one is the data collection module, and this one is the sensor node. The sensor node, we have this one is a control unit here. And in the previous section, we talked about the power supply. Because the device were put into the farm, so we need the power that can supply the device to work. So we use the solar panel here to get electronic power and to make the device work. And then the data, when the data sent to the cloud, and another form of the data, we can use the open data. Some data can, just like the weather information, we can use the server to get the data from the open data. Okay, such like the weather information. This is the sensor. We can detect the soil moisture, and then we can send the signal, send the data to the sensor node. And the sensor node can transmit the data to the data collection modules. Okay. And here, because I am focusing on the software, so we are just using the existing hardware. All this one is the existing hardware, but we need to relay out. We use the PCB board to relay out the board and put the electronic component in one board. That can use to save the more power. Okay, and this one is the sensor, the moisture sensor. We can put it together, and this box is printed by the 3D printer. Okay, and this one is the control. We can use the control units to control the water. That's control signal is sent from the cloud. Okay. So this is another thing. This one is the data collection box. This is inside the box here. And this one is the unit of the data collection box here. So the data collection box is receiving and passing the control to the sensor node. And this one is the modeling component. When the data come to the cloud, and then we can collect the data. This one is time, and this one is the data node ID, and this one is the sensor ID here, and this one is the soil moisture value, and this one is the soil temperature, and this one, let's see. Okay. And this one is the humidity, and this one is the temperature of the weather. And this one is the temperature and humidity and the sun. This data is come from the open data, okay? And we put all this data together. And then we can use the data preprocessing to reform the data here. Okay, and this one is the information from the plant. And then the second step, we use the data to create the model. Before we want to create a model, we need to pre-processing the data because, for example, this one is the day 1, day 2, and the day n. We need to stop the second day. This one is the humidity in the second day, and this one is the humidity in the first day. We subscribe the second day into the first day, and then we got the value here. Okay, and we use the pre-processed data to create the model. The tool we use to create the model is the data mining. We use the data mining and to generate a association lure. The lure is here. We can generate the lure, use the previous data. And then the last module is the prediction. We can use the information, the current information that's get from the sensor node and put the data into the model, and then we can make a prediction. Okay, there is an example here. For example, this one is the January 1, January 2, and January 28. There is the humidity value for the first day and the humidity value for the second day. And then we use the previous data to create a lure. Is here. The lure is here. And then for the January 29, we got the information from the sensor node. We put all this data into the model. And then we see which lure fit the data that's get from the sensor. And then we got prediction value is here. So when the January 28, we can predict the value for the January 29, January 30, and January 31. We can predict the value and make a decision if the water is ready to put into the farm or not. Okay. So for convenience, we need to generate code to make some code for the user interface. This one is the login, and this one is the mobile UI to control the device and make a lure here. And maybe we can make a picture of the farmer here and make a prediction where you can open the water or close the water or make the water open or close automatically. Okay. This is the UI here. So we put the product into the real form here, just like this one. This one is the GPS. You can put this device in every place of the farm. And this one is put into the garden. Okay, and this one is the package of our product. And we can make it into one box here. So this product has been applied for a patent in Taiwan and make a contest in the Taiwan Innovation Technology and make a silver medal here. So I think this one is a simple application on the agriculture. So that is a small idea, and maybe some students can make it more useful in other fields. Okay, that's it. Is there any question here?
Okay, thank you, Prof. Chang. Congratulations for your achievement.
Yes.
It's very interesting.
It's a small project, a prize in agriculture.
Yeah. We have a department also for agriculture department that I think in the future, I think we can make some collaboration project because we have a department that focus on the agriculture. And last time they talking about smart agriculture, smart precision agriculture for monitoring the land, the paddy land, I think, paddy field, sorry, paddy field. So really hope that in the future we can, I think, make some collaboration for research or another type of cooperation, I think.
Yes.
So for your student, any question from student? Okay, because it is the last.
Yes.
Okay, sir. And also we have some course that focus on the IoT, Internet of Things. We make some device that make some device for IoT. Especially because our department is focused on information technology, so we focus on the development of the software on the cloud platform, in the cloud in the cloud layer, I think. And we try to make some connecting with hardware. We make a gateway for connection between hardware to cloud. So it is still our project now. I think we can talking about maybe some collaboration, I think, in the future.
Yes. I think the IoT, we can divide the IoT into two parts. One is the thing and one is the internet. I think there's two parts here, but I think my focus is on the internet part, because my interesting is in the just like the AI, artificial intelligence, maybe data mining, data pre-processing, just like this part. And maybe on the thing part is in electronic department.
So you're focused on the cloud layers, right?
Yes, right. So, for example, just like this one, just like this one, and maybe you need to redesign the chip and need to lay out the PCB. I think it's more related to the electronic part.
Okay, for packaging, right? For packaging. Okay, sure. It's very interesting. We hope that we can talking in the future in another session. Thanks for
maybe
coming.
some students are interested in the IC design, and maybe the SMC. You can try this one.
Yeah.
We have a tool to design the IC. Yes, but there are a few students are interested in that part.
Okay. Okay, thank you, sir, for your sharings about your project and your knowledge about IoT. Thanks for your coming in our visiting professor program. And we hope, and we really hope that in the future we can collaborate. We can make collaboration in another form of cooperation, like join research or another. Thank you for Chang for your time. Bye bye. See you again. Thank you. Oke, teman-teman, lecture-nya selesai ya. Nanti kita upayakan ada sertifikat, nanti kita kirim ke teman-teman. Nanti kita proses dulu. Dan juga nanti hari hari Sabtu Minggu ini juga ada kuliah 3-in-1, tapi dari praktisi. Dari perusahaan akan berbicara mengajari tentang pembuatan ini ya, web ya, aplikasi web. Di kuliah dari praktisi. Jadi insya Allah Sabtu Minggu ini. Dan minggu depannya juga ada lagi dari praktisi juga tentang IoT. Jadi praktek, mungkin nanti praktek ya, bikin aplikasi IoT. Oke, terima kasih untuk teman-teman semua. Untuk yang kelas saya, habis ini saya kirim soalnya ya, untuk UTS-nya. Ada pertanyaan mungkin? Nggak ada ya? Oke, terima kasih atas waktunya teman-teman. Nanti sampai jumpa di kuliah 3-in-1 yang berikutnya ya. Oke, terima kasih. Selamat sore. Assalamualaikum warahmatullahi wabarakatuh.